Hey friends, welcome back to the channel where we geek out on AI stuff. Since you've seen my earlier videos on things like embeddings, which are just number codes for words meanings, tokens, RAGs, that's retrieval augmented generation, a way to pull in extra info from databases, and graphs, we'll skip the deep dives there. Today, let's chat about how a powerful large language model, or LLM, like GPT-5, that's the next big version of OpenAI's AI, building on GPT-4, handles context, keeps things making sense, and seems to think deeply. I'll keep it super simple, explain terms as we go, and not overload with examples. Let's jump in. First, context isn't saved like notes in a phone. It's built fresh each time. When you type a prompt, your words get broken into tokens. Tokens are like small building blocks, numbers representing words or word parts. These go into a transformer, which is the core brain of the model, a stacked set of layers that process info. Each layer uses self-attention, basically checking how every token relates to others, giving weights like important scores. For instance, the uncle sold hot sweets by the stall. They were crispy. Attention connects they to the sweets, not the stall. It learned this from training on tons of text. So no real memory, just quick rebuilding of connections. For deeper context, it's about handling long stretches of text. Older models like GPT-2, an early version, could only manage short bits, but GPT-5 can handle up to 1 million tokens, like reading a whole long story at once. Think of it as a big web. Tokens are points, attention weights are links. Layers refine it. Early ones fix basic structure, middle ones get the meaning, later ones catch tone or purpose. It strengthens key links and drops weak ones, keeping the flow smooth over lots of words, like a family chat that stays on track. Understanding isn't like human thinking. It's smart guessing based on patterns from training data. The model predicts the next token using stats. But since the data includes organized stuff like stories or plans, it captures real meaning. Say you ask, explain rainy season work like I'm a kid. It spots the topic, rainy times and style, simple, mixes their codes and picks a response that fits. It feels smart because the patterns are so detailed. Now that deep thinking comes from hidden smarts in the model. Parts of it specialize. Some track who he means, others handle logic like, if this then that, or basics like rain makes things wet. For a tricky question like compare old ideas on fate with virtual worlds, it combines these parts, recalling ideas, linking examples, blending time concepts. It's like teams working together, all from training to guess text accurately. To keep context going, it squishes old tokens into summaries and uses loop-like tricks. No saving across chats, but in one session, it rechecks early parts to tweak later ones, like adjusting a plan as you go. For extra help, RAG pulls in outside facts. It turns your question into a code, searches a database for matches, adds them to the prompt, and blends everything. This makes context endless. Graphs structure knowledge like maps, helping jump between related ideas, say from worker to rain to output. Multimodal means handling more than text, like images or sounds. GPT-5 turns a picture into codes that mix with words. Upload a wet field image and ask about patterns. It links to ideas like rising water or drops. Why does it seem like thinking? Layers build from basics to big ideas. Attention weighs long info, parts specialize and guesses feel put together. It's like simulating a web of meanings, following rules from training, projecting what comes next in a smart way. Quick example to wrap. If a vehicle must swerve hit a hole or an animal, which? It sees ethics, checks outcomes, recalls similar dilemmas, decides, hole is just dirt, animal is life, avoid harm. Looks thoughtful, but its probability flows. In short, LLMs like GPT-5 handle context by rebuilding token webs on the spot. They think deeply by refining guesses in layered spaces. With RAG graphs and multimodal tricks, it's close to real reasoning, all computer